Hey, I'm Ernesto, one of your tutors, and welcome to the first video for Math 1. So today we're going to be learning about variables and how to solve for variables. To begin, we're going to define variables. So variables are basically, in math, these mystery numbers that we don't know what the values are, but we want to solve for them. So usually we tend to use letters to represent what these variables are. For example, in this first equation, we do have three variables where we have x, y, and z. Yeah, so these numbers are basically just there in place for these mysterious numbers that we do not know yet, but we will solve to get. So actually for these first three questions, we actually have the values of x, y, and z. So all we really have to do is plug in these numbers instead of the variable and solve for your equation. So first thing we're going to do with these equations is that we need to see what we need to multiply, add, subtract first. So we do see that we have the y squared, and according to PEMDAS, that does take priority over the rest, like for example this, which by the way basically just means 3 times x. And will be the first thing that we do in this question. So what we're going to want to do is, instead of y, because we know that y is equal to 4, what we can do is place the 4 instead of the y, where instead of saying y squared, it actually will say now 4 squared. Well, we know that 4 squared is just saying 4 times 4, which is equal to 16, so we know that'll be our final value. The next order of operations that we're going to want to do is multiplication, according to PEMDAS. So we do see that we have 3 times x. So what we can do, like how we plugged in 4 for y here, we can plug in our value of 3 for x, or our value of 3 for x, and solve from there. So notice this is 3 times x. If we plug in the value of 3 for x, it'll basically say 3 times 3, which is a total of 9. Right, and because we're not really affecting the plus and the minus sign, what we can do is drop them down to the final equation, because it's going to be the thing that we do at the end. So here we have z as our third variable, and we do see on the right side that z is equal to 1. So all we have to do, because we're not multiplying, no dividing, nothing like that, all we really have to do is put in the value here. So we do have 9 plus 16 minus 1. Right, so here all we have to just do is just simple addition subtraction. 9 plus 16 is 25, minus 1 is a total of 24. And that'll be how you solve for the first one, where you have your variable values given. So now we're going to move on to another practice problem, number 2. So in this equation, we do have the value of x is equal to 9, the value of y is equal to 4, and the value of z is equal to 2. Right, so in this we're going to want to do the same thing, where we plug these numbers into their values and then solve. So we do see that this number has the squared, and again, going back to PEMDAS, exponent takes the second most priority, so we know that's going to be the first thing that we want to do. So this is basically saying 4 times x squared. We're going to do PEMDAS, or we're going to do the exponent first, so it'll be 4 times 9 squared. Right, and from here all we have to do is do 9 times 9, since we know that it's 9 squared, so it'll be 4 times 81. Right, and from here you guys can grab a calculator if you want. I'll do the 81 times 4 on the side, just because I don't have a calculator with me right now, but it will be a total of 324. So we're going to drop that down to the bottom, we're going to drop that minus sign down, and we're going to go with 8 times y. So we know that the value of y is equal to 4, so we know that this part of the equation is telling us 8 times 4, which is equal to 32, and that'll be what you drop down. So it'll be 324 minus 32 plus 3z. We'll do the same thing that we did here, where we plugged in the value of y is equal to 4. Instead, we'll look at the z, and we'll see that z is equal to 2. So we know that this is telling us 3 times 2, which is equal to 6. We'll drop that down, and we have 324 minus 32 plus 6. So a thing that I like to do is that I try to see what's the easiest way to solve for this. You could solve from left to right if you wanted to, but what I see here is that we can add these two together, negative 32 and 6, and we will get a total of negative 26, and then we'll drive down to 324, and we get 324 minus 26. We could also further split this down where it's basically saying minus 24 minus 2, because when you add these up together, it's typically going to go back up to negative 26. And we can drop down the 324 here, and we can solve from here. So the first thing that I do want to focus on is going to be the minus 24 part. So we have 324 minus 24, which is going to land into a total of 300, minus 2, which is equal to 298. That is how you get the answer for your next problem. Now we're going to move on to number 3. I'm going to give you guys a little bit of time before I work on it, just so you guys can test out your skills, test what you've learned and see if you can solve it. All right, so we're going to go directly to solving it. So here we have negative 4x plus 2y squared minus 3z. And we have the values of x is equal to 2, y is equal to 3, and z is equal to 5. We're going to do the same thing that we did before, but we plug in the values, and again, we have the 2y squared. So we know this is the first thing that we want to do, where we're going to have 2 times, we have y is equal to 3, so it's 3 squared, which is equal to 2 times 9, which is equal to 18. Now, we do see that these two are essentially the same thing, where this is saying 4 times x and this is 3 times z. So it doesn't really matter what you're going to want to do next. I'm going to go with the negative 4x just because it's in the foremost left side. So we do have negative 4, right, times your x value, which is 2. And negative 4 times 2 is negative 8. So we're going to drop that down. We do have the plus symbol here, so we're going to do negative 8 plus 18 minus 3z. Your z is 5, so we have 3 times 5 is equal to 15. So in total, your equation will be negative 8 plus 18 minus 5. We can add these two up together, which is going to be 10, and then we're going to subtract the 15, which will get us to a total of negative 5. So yeah, that's basically how you solve when you're given the variables. But now we're going to go over to questions that ask you to solve for the variable. So instead of being given these values, you will have to find the values yourself. All right, so now we have a different looking equation where we have 3 plus 2x is equal to x plus 6. So what you want to do in these equations is that you want to figure out what the value of x is equal to that will make this equation true. By what I mean as make this equation true, I mean by both sides will be equal to the same number. So what you're going to want to do is that you're going to want to get your equation to look like x is equal to this mystery number. The value of x will be different depending on your equation, but it will always end up like this, where your answer will look something like x is equal to, say, for example, 6. X is equal to 6, right? So with these types of problems, one thing that I do like about them is that technically you can start anywhere. There is more efficient and faster ways of starting, but you can technically start from wherever you feel like, and eventually you will get your answer. For this one, I'm going to show you the more efficient way, where you kind of like get the x's all on one side and you get all your real numbers on the other side. So what I do see here is that there is a 2x on this side and a 1x on this side. So in solving for these equations, one thing to take note is that whatever you add on this side, you will also have to add on this side. This also goes vice versa with subtraction, addition, multiplication, division, all those things. Whatever you do on one side, you will also have to do on the other side. So for example, we'll start off by subtracting x on this side. And that also means that we'll have to subtract x on this side. So when you're adding or subtracting an x, it only affects other variables that have an x. It won't affect, like, for example, On this, the negative x will not affect the 3, it will only affect the 2x up here. So when we're solving this, the 3 comes back down, plus this is 2x minus x, which is just equal to 1x. So 3 plus x is equal to x minus x cancels out, that makes 0, and that leaves the 6. So we have 3 plus x is equal to 6. Now all we need to do to have x on its own on this side is that we need to subtract the 3. So subtract 3 on this side, and subtract 3 on the other side as well. So we have x is equal to 3. So now that we have what the x is equal to, what we can do is we can actually verify that this x value is true for our equation by plugging it back into the original function. So we have 3 plus 2x is equal to x plus 6. We'll plug in 3 for x, so we have 3 plus 2 times 3 is equal to 3 plus 6. This is multiplication. 2 times 3 is 6, plus 3 is equal to 3 plus 6. Now we can see on both sides that it says the exact same thing. 3 plus 6 is equal to 3 plus 6, and that gets a total of 9 is equal to 9. We can check mark that because both sides are equal to each other, meaning that this is right. So moving on to the next question, this one's a bit more complicated because it adds one extra step at the end. So I want to show you guys that it doesn't really matter where you start. Eventually you will get your answer. So for example, on this question, I'll start with the 4. And by what I mean by starting with the 4, I mean that I will get rid of the 4 on this side. What I need to do is just subtract 4 on both sides. That'll cancel out the 4 right here. That'll leave me with just 6x is equal to 2x isn't affected by subtracting 4, so that comes down. The 20 will be affected because they're both whole numbers, so this is 20 minus 4, which is equal to 16. So it'll give me to 2x plus 16. Now I do see that we do have 6x on this side, 2x on this side, and 16 on this side. The next step is just to remove the 2x on this side. That way all the x's are on the left side and the whole number is on the right side. It doesn't really matter which side they are in. Technically, going back to like the first question, you could also get the answer where it's 3 is equal to x. They both mean the same thing. So yeah, just wanted to point that out. We have 6x minus 2x, that's 4x is equal to 2x minus 2x cancels out. And we have 16. 4x is equal to 16. So technically we do have something very similar to what we're trying to get, but what we want to do is we want to just we want to get it down to the most singular variable possible, as in we want to get this 4x down to 1x. So we know that addition and subtraction won't work on this. If we subtract 3x on this side, that'll basically get us with x is equal to 16 and then the minus 3x. That won't remove the x on both sides. So what we can do is instead of adding or subtracting, we can actually divide. So if we were to divide this by 4 and then also divide this by 4, this will cancel out the 4 divided by 4. That'll leave us the x on its own. So we have x is equal to 16 divided by 4, which is equal to 4. Right, so now that we have our answer, we can do the same thing that we did on the first question. We can just plug in our 4 for the x value in the original function, where we have 6x plus 4 is equal to 2x plus 20. So it's going to be 6 times 4 plus 4 is equal to 2 times 4 plus 20. 6 times 4 is 24. We have 2 times 4, which is 8. And then we're just going to put in the plus value, so it's 24 plus 4 is equal to 8 plus 20. And now that we just have to add these two together. So we have 28 is equal to 28. So we do see both sides are equal to each other. So this is right. And now we'll move on to the third question. And yeah, for number 3, I'm going to let you guys try it out. I will have the answer down in the description along with another worksheet if you guys want to try out similar questions to these. Next video, we will be going over one variable statistics and how different graphs are used.